Hello, good day, and thank you for joining us today in our roundtable discussion on the Green Radiology Department. I'm Boris Brkljačić. I'm Professor of Radiology at University of Zagreb School of Medicine, and I'm past President of European Society of Radiology. Joining me to co-chair this session is Adrian Brady, first ECR Vice President and a consultant radiologist in Cork, Ireland. Thank you, Adrian, for co-chairing this session with me today. The topic of sustainability is a crucial one, and in this session we want to explore its implications for radiology departments. We want to learn about the ways to achieve a sustainable and long-term energy-saving radiology department. Joining us to take part in these discussions today are 6 experts on this topic. Professor Joachim Hochmann from the Department of Radiology and Nuclear Medicine at the Cantonal Hospital in Winterthur, Switzerland. Professor Francesco Sardanelli from the Department of Biomedical Sciences for Health at the University of Milano, Italy. Professor Andrea Rocal from the Imperial College Healthcare in London, United Kingdom. Professor Lorenzo Derchi from Genova, Italy, ECR past president. Professor Luis Marti Bonmati from the Department of Medical Imaging at the University Hospital La Fe in Valencia, Spain. And Dr. Kees Wesdorp, Chief Business Leader Precision Diagnosis and jointly responsible for diagnosis and treatment at Philips. Welcome all. Before we start with the roundtable discussion, we will first hear a short introduction from my co-chair, Adrian Brady. Adrian, the floor is yours.
Thank you, Boris. And I'm just going to share a few introductory slides with you that are derived from this Canadian paper, which is really interesting and summarizes many of the things that we will be talking about today. It appeared in the Canadian Association of Radiologists Journal in 2017, and Professor Rockall will be elaborating on some of this material later on in her talk. But the paper outlines 4 principles that are key to greening a radiology department: utilizing less energy and water, generating less waste, using biodegradable materials, and proper disposal and recycling of waste. There are a few ideas in that paper that are perhaps a little bit amusing, but interesting ones that can help any department in reducing their energy footprint. For example, if anything is being printed, they suggest that all printers should be set up to default double-side print to reduce paper usage. They suggest that patients should be encouraged to wear clothes without buttons or metal when coming for their studies, so that they may be able to have those studies without having to change into gowns and thereby reduce laundry requirements. More controversially, they suggest that tissue paper consumption in the toilets could be minimized by using a dispenser, only giving 1 piece of paper at a time instead of having an entire roll. I'm not sure how much we could adapt our systems to that. And finally, they suggest that water hippos should be used in the toilets to save water. And if you don't know what a water hippo is, it's not this. It's just a container that can hold up to about 2 liters of water in toilet cisterns to reduce the amount of water that is required to refill the cistern after a flush. So with those rather trivial comments, we'll move on to the more serious aspect of this topic and invite our first speaker, Professor Hochmann, to the podium. Thank you.
First of all, I would like to thank the organizers to invite me to speak about this topic, which is very important for me. Even I just have only a small part to present, and I'm talking about reporting stations. So because it's a small part, we call it Green Fingerprint Project instead of Carbon Footprint Project. And to keep it short, we measured the power consumption of 32 reporting stations over a time of about 200 days. And we recorded the energy consumption every minute with a data logger, and we finally came up with about 10 million readings. And the further statistical evaluation used the active power and was done with our statistical software. So to go in more detail, we just measured the reporting stations altogether with all things which are standing on the desktop, for example, the lamps. There were mobile chargers and so on. And then we analyzed for all reporting stations the data to allow everything for comparisons. So these are the results by the reporting station, and you can see there are some reporting stations which consumes less and some which consume a lot of energy. These are the stations which are all the time on 24 hours, 7 days a week. And what's more important is that we found 3 main patterns of consumption, which are shown here. And these are, the first is mainly off. You can see that the main histogram part is around 100 watt power consumption. And when you compare it to the other graphics, you see here is mainly on. The main power consumption is around 400 watt. And there are some bars in the middle. And these bars are the bars when the reporting stations are in a standby modus. And we also have some stations which are always on. They are just on and at some times in a standby modus. So when we look at this, we concluded that the different distributions are mainly due to the standby mode, which are usually S1 ACPI states. I will come to that later in the next slide. These states were configured to be activated after 4 hours of inactivity. So, however, as we saw in these graphs, even in the default standby mode, a reporting station consumed around half of the power of the on-mode states. So we created a first simple scenario to save energy. But just will make you a little bit more confident with the ACPI states. There are at least 5 S states, which are the most important stage here. And as I talked about, I said there is the standby mode is usually S1 stage. And in the S1 stage, most of the power is still on, and there's only a few reduction of power consumption in the S1 state. Much better states are, for example, the S4 states or even the S5 stage, in which is the reporting station turned off completely. So these are the results by mode. You see the on mode is about 40,000 kilowatt hours, and there's a standby mode with about 10,000 kilowatt hours. And the scenario we put, we found that most of the times, no, not most of the time, but half of the time, the reporting stations are idle. They are waiting for standby. So these about 18,000 kilowatt hours. And if we changed our standby modus to a modus in which the reporting stations just wait for 1 hour to shut down and then shut down completely to a S4 or S5 state, we can save about 24 kilowatt hours just in our department. And this is a total saving of 45%. Going a little bit more in the real world, this is the overall power consumption we found in all the reporting stations was about 15,000 kilowatt hours. This is equal to a power consumption of 12 family households in Switzerland with 4 rooms, or it's about 9 passenger vehicles driven for a year, or about 100 barrels of oil. And we could achieve an energy saving of about 24,000 kilowatt hours per year. And if we extrapolate this number from our relative small country, we came up to about 1,500,000 kilowatt hours per year, which we can save with this very easy scenario we made. So this is my last slide. I think it's very important to be aware that the reporting stations are consuming power, consuming energy, and this is the most important thing, that we be aware. So there's another part, I think we will hear about this part later on, the technical development. This will not stop, and I think there are some parts which can save the energy, for example, the use of SSD drives instead of hard disks. And as I said, the use of higher ACPI modes instead of lower ACPI modes, but we have to be aware that this has to be done actively by our staff, by the radiologists themselves. So I think we will have I will have pointed out my study, and I think we will hear about these topics or other topics which will reduce energy waste later on as well. Okay, thank you.
Our next speaker is Professor Francesco Sardanelli from Milano, Italy.
Thank you, Boris. It's a big honor and pleasure to be with you and with our audience to discuss how to change, that is, the words of our Congress, time to change, also from the viewpoint of environment protection. And I will try to share with you what is the Green Water Project that we will carry on in my hospital in the next months. So the point is that thinking NCT and MRI, the number of examinations are ever increasing in the world, with millions and millions of CT scans and obviously also of doses of iodinated contrast agents and millions of gadolinium-based contrast agents every day, every year, all over in the world. So the point is that these pharmaceuticals compounds are mostly excreted without metabolization. The first ones are derivatives of 3-iodobenzoic acid and are mostly used in intravascular administration. They are different chemical structure, monomeric, dimeric. You know, some of them are shown in the slide. On the other side, gadolinium-based contrast agents are complexes that are chelated of the trivalent gadolinium ion with polyamino carboxylic acids. And so the toxic effect of the free gadolinium is avoided, and renal excretion again happens without metabolization. There are adverse events with these important chemical compounds, differently from the two classes. For the iodinated, we have short and mid-term effects, hypersensitivity reaction and contrast-induced nephropathy, with all the rules that we follow in our department to decide to administrate or not to administrate these important contrast materials. The scenario is quite different from the gadolinium, that is a never-ending story, as you know, because we can list short, mid, and long-term effects of gadolinium. based contrast agents, including hypersensitivity reaction, nephrogenic systemic fibrosis, and also gadolinium retention in the brain and other organs. And last but not least, also the so-called SAGE, so the symptoms associated with the gadolinium exposure not yet been scientifically verified. Fortunately, as you can see from the graph at the bottom of the slide, the curve of the concern about MRI gadolinium deposition in the brain, taken from the number of papers published available in the PubMed, is quite declining. So probably also in this case, the story of the gadolinium will come back to a new normality after excluding the linear agents, especially in the European side. However, ecotoxicological effects of these agents have to be considered. There is an abundant literature about this. For example, in 2011, Kormos and co-workers showed that we have 46 transformation products of iodinated agents detectable in aquatic environments before wastewater treatment, but 26 of them persist after the treatment. Another paper showed that there is anthropogenic gadolinium in wastewater treatment plants of rural areas, attributing to patients who undergo MRI as outpatient and then return home. So we bring gadolinium also in rural areas. These are some examples of published literature about presence of iodine as an ecotoxicological effect, but there are many other papers, and these are other papers regarding are increasing amounts of gadolinium in surface and tap water dangerous? So this is an issue we have to consider, and it's known that in rivers near big cities, we are able to demonstrate that there is gadolinium or iodine in the water. There are European and also Italian projects in which this topic is specifically addressed, mainly try to reduce the pollution from dangerous substances, high concern and toxic materials, in particular from pharmaceuticals. This is not a matter only of contrast agents, it's a matter for all pharmaceuticals. But this is what we can do as radiologists for the environment. There are many countries in which there are projects addressing the problem of reducing the gadolinium and the iodine in the wastewater in different countries in Europe. What we want to do in my department at the Policlinico San Donato in Milan is to prospectively monitor over a 12 months time frame the quantity of retrievable iodine and gadolinium from the urine collected from outpatients within 1 hour from the administration. And also to assess the rate of acceptance to participate to the study by the patient according to age and sex and other socioeconomic variables. So we design a monocentric study in which we will enroll patients undergoing scheduled contrast enhanced CT or contrast enhanced MR without modification of the clinical protocol, with an observation time of 30 minutes extended to 45 to 50 minutes with a total time span after the administration of 60 minutes. And we will collect the urine in this time period, and we will store the sample at the biobank of my hospital. So the idea is to use the first month for CT, the second for MRI, and again for the fourth for CT, the fifth for MRI, going along the seasons, considering that the level of hydration of patients could be quite different. So we want to see what is the change also in relation to the external temperature. We will include patient with this inclusion criteria and exclusion criteria. It's important to note that we have to exclude previous infection disease in the last 2 months, not to enter in regulation for moving samples containing infected material, because this could be a problem also from the viewpoint of regulations. We will analyze probably the first 200 also patient by patient, but the main project is to look at the difference between young males and young females, older males and older females, differentiating for age and for sex. This will be the 4 groups for which the analysis will be done overall, considering season and other variables we are able to collect. I don't want to bore you to statistical and sample size, so we will think to enroll 800 patients in 12 months and to create a model for foreseeing what is the rate, the amount of gadolinium in the iodine that we can able to avoid to put in the environment. Only ask the patient to stay 30 minutes more compared to what is the standard in the department. So the expected results are to be able to see what is the amount of gadolinium we are able to prevent to enter unmonitored sewers with a small extension of the observation period. Also to calculate, to see what is the real acceptance rate by the patients. So in some way measuring what is the green sensitivity of our patients. And we believe that this data will prompt the design of future multicentric study and to propose specific systems or devices to reduce the quantity of iodine and gadolinium derived from contrast agents reaching aquatic environments. I thank you for your attention.
Thank you, Andrea, for this very comprehensive and excellent lecture, which all 3 presentations touched very important issues. And it is now time for our roundtable and asking questions to our panelists. Please, Adrian.
Thank you, Boris. It's a fascinating topic, and as I said, I think one we'll hear more and more of. It also ties in very nicely with the whole value-based radiology concept that is another growing area of interest in radiology. And given that one of the goals of that is to improve the value that radiology delivers to society as a whole, I would see the measures that our 3 speakers have spoken about as a great thing that we can do to benefit society. Perhaps it may not be influencing patient individual outcomes, but it can be of great benefit to Andrea's world and the world of the future. Could I address my first question to our guest who's with us online, Dr. Keith Westdorf from Philips? You've heard the call to arms from Professor Rocco. What is industry doing? What can industry do on a practical basis to address these issues of energy consumption with the high-level equipment that you produce?
I love indeed also Andrea's world and how that ended. I heard the call out loud and clear, and I couldn't agree more. So maybe coming back to our overall mission of we need to expand access to care, as 50% of the population is still not having access to the right quality care, and it goes in hand when doing that in the most sustainable manner. I, as a leader within Philips, and Philips as part of industry, have a fundamental role to play. And across the 3 presentations, you could clearly see it's urgent. Time is now to act, and there's ample opportunity to do that. But it does require a partnership between industry and health systems. In the presentation, you heard examples in the engineering domain. I'm the first one to agree with that, absolutely. And we can do that. So reducing idle time or leveraging the heat that comes from these systems and reusing that are things that we're actually working on today. And more importantly, we've actually kicked off the Closing the Loop program. And the Closing the Loop program has the ambition by 2025 to get all the equipment back that's in the field and giving that a second chance, either through refurbishment or through parts harvesting and giving those a second chance. That's not a dream, that's something that we do already today. And you're fully right, we need to embrace that more. The other point that was made, and for instance, we're working with Vanderbilt on an energy baselining exercise, because we saw those opportunities today. But does a health system that is contributing 4%, sometimes more, of carbon dioxide emissions to the world, does a health system understand what the sources of that are? What are the largest items in the Pareto that need to be addressed? And so the energy baselining, the CO2 emission baselining, the footprint baselining is critical. And that's where insights and tools come into play. And we're actually developing those as an industry partner as well. The third is, and we touched a bit upon that, is the role of informatics. For instance, the examples given in the first presentation to go from solid state disks, from hard drive, disk drives to solid state technology. But what if we would go towards the cloud and leverage there the economies of scale and reduce on-site servers completely? That will be yet another push towards a much greener environment. And informatics is going to play a much larger role as we move forward to decarbonize the footprint that's out there in the field and leverage more the economies of scale and scope of cloud technologies and informatics at large. But thank you for the call out, and it definitely kept me on my toes to do my best in making the planet better for the next generation.
Thank you, Dr. Westorff. May I just pick up on one thing you said and direct a question perhaps to Luis Martí Bonmatí, who has a particular expertise in informatics. You suggested that moving from having local servers to cloud-based data harvesting and data control will reduce energy consumption. But surely cloud-based services are hugely dependent upon very large data centers, which we know are big energy consumers. Luis, as an expert in informatics, do you have any thoughts on this?
Well, I'm not pretty sure on that, because as you said, also on the clouds, we are using servers there everywhere. Mm-hmm. But maybe it could be more efficient to take control on the consumption when you have all those servers together. Mm-hmm. That's my feeling. It will be much easier than at the, let's say, local base. Mm-hmm. So maybe that's one line to take care of.
Okay. And maybe if I may add that, I would concur with that, but it's also our responsibility to make sure that the partner, the cloud technology provider, has a green approach. And so, for instance, if we would partner up with Amazon or AWS or Azure, then making sure that we do that in a supplier certified way, such that the energy is also sourced in a green way, could be another step in the right direction. And that's what I mean with both partnering up with health systems on the one hand, but also making sure that the suppliers for our technologies become greener and greener.
We have received in our chat a question from Fiona Gilbert from Cambridge. Is it possible to use the energy performance certificate for all imaging equipment? So I would like to ask our experts in the studio, Professor Martí Bonmatí and Lorenzo Derchi, what you think about this.
Well, it's a kind of energy certificate is for washing machines and fridges. Mm-hmm. So possibly we can also have it for medical equipment. I think it could be, but as in some slides I've seen, we need some kind of regulation from the EU. Yeah. Yeah. And this can be maybe, let me say, an initiative that the radiologists make together with the industry to have to launch the idea, and even if it be somewhat expensive, but it can provide on the long term some savings to the expense of each hospital and to the environment. Yeah. That could be a good idea, a good move to make it together.
Also, if I can add, I do see a role for the European society to highlight which are the standards or the checklists companies should fulfill in a transparent way, so we will know when we acquire equipment which is the level of sustainability, climate change level, environmental actions related to those machines we are buying. So I really agree we should have those checklists on a transparent way, so we will be able to compare between the different vendors.
And this might be one of the things in procurement processes that we look at.
Right. Yes,
and
exactly.
Value, right? Mm-hmm.
Could I address a question to Professor Sardinelli in particular? The green water project that you mentioned is really interesting. There was a paper published within the last month or two in Insights from a Dutch group, I think, which addressed the issue of contrast products, BIPOC products going into wastewater, exactly the issue that you're interested in. And one of the solutions they suggested was giving patients urine bags to bring home with them to use for a given period of time after their study. But then those urine bags would have to be disposed of course, and in effect they would end up going into landfill. So what's the environmental impact of that as opposed to having it go into wastewater?
So my view is that we have to consider that the project is addressed to outpatient, but something more can be done also in inpatient because they stay all day long in the hospital. However, for the inpatient, that is all the problem of the of possible infection that is not easy to manage in terms of managing the samples and so on. What is the perspective? The perspective could be can be different. One possibility is to stay more than 1 hour, but we have to verify what is the sensitivity of the patient for this. So one of the most important results of the study is to check what is the availability of patient to spend 30 minutes more to save the environment. And the other one is to think about to change the building of the radiology department, having bath services similar to nuclear medicine, in which they have the problem of radioactivity. We did not consider up to now that gadolinium and iodine can be considered dangerous, not as technetium, obviously, but it's something similar to have different bathroom for patients dedicated in order to, or to have devices able to retain. There are experiments about nanomaterials for this that could be used for retaining the gadolinium. And this could be also useful for the viewpoint of saving rare earths that are difficult to find in different countries in the world. What I want to highlight, especially in these dramatic days in Europe, is that the problem of energy, that is a strategic one, theoretically can reduce the sensitivity to the green matter. Because if you don't have heat in your home, you may be probably more sensitive to save the environment. But if we have an approach in which on the one side we reduce the energy consumption, and also we reduce the wastewater of dangerous materials, we can put together the two issues, not losing on the one of the two sides, I think.
May I?
Thank you.
Yeah, it has been somewhat addressed in some of the slides, but the best way to achieve a green radiological department is to use wisely the techniques that is. We have to do the right examination to the right patient at the right moment and nothing more. In the Western world especially, the great problem is consumerism, which leads to erode the resources of the planet. And there is also a lot of consumerism in healthcare and in imaging. We do, I would say, a lot of not very, very indicated examinations. And we have to work hard to reduce this number.
Maybe also we can add that there is a need to reduce the impact of what we do. And on contrast media, we can also reduce as a mitigation procedure the contrast media doses. I mean, because they are in a transparent way, maybe we should report if we are adjusting doses by weight. If we are adjusting doses also by heart rate, there is a new paper now that you can reduce contrast media by taking care of that. If we are also taking care of collecting the residuals of the contrast media, and instead of throwing them to the waste, we put them on a special burns or to be reused also for no contrast media production. And my feeling is that this transparency methodology should be published. I mean, we should publish in our own departments what are we doing for the best of the environment, because this is at the end one health, no? I mean, it's the humans, animals, and plants, and we are all together.
Yeah. And there is another issue regarding how to combine this approach with personalized medicine. Because to recover the gadolinium or the iodine in an old patient that has a low estimated GFR and a low dose can be useless compared to a young with a high dose. So we should have models in order to predict what is the contribution that each patient is able to give to this project, because it's possible that for some patient is relevant, for other patients is not, depending on the age, the GFR, and the doses we administer. Also thinking about that, the possibility this could be not a good news for the companies, but using artificial intelligence, we should be able to reduce strongly the doses of the contrast. There are papers published in which with deep learning, you are able to reduce for 90% the dose of gadolinium, generating virtual images that give you the same contrast with 10% of the doses. So there is a world to explore, to reach. So you can recover more gadolinium at the end of the process, or to inject less gadolinium at the beginning, you know.
Yeah, yeah. Could I raise another question, which is moving the discussion in a slightly different direction? And I'd like to perhaps address this first to Professor Hohmann and then Professor Rocco. What has the impact of COVID been on our environmental credentials as hospitals and as radiology departments? I mean, certainly in my hospital, I've seen a huge increase in the amount of waste generated because of COVID precautions, masks, PPE. Obviously, much of this was necessary, but it has worsened our environmental performance over the last couple of years relative to previous to that. I've seen a huge increase in the use of single-use disposable items like cups, all drives to move towards reusable stuff that were ongoing previously were halted. What have you seen in Switzerland or in the UK? And do you think we can get back to where we were before COVID?
Yeah, in Switzerland we have, I think in most European countries, at least in most European countries, a lot more of single-use materials in a hospital. As you said, masks and cups, non-reusable cups. But this is, this is due to the special situation in this COVID area, I think, and this will not stay longer after we come in these endemic state. So then we can reduce these parts to a state as it was before, I think, and then we have to go further, and we have to reduce it more than before. For example, in our hospital, we try to use reusable cups instead of non-reusable cups, and we try to use reusable, I don't know, everything. We try to use everything reusable as possible. It's not everywhere possible, but I think we try it. So.
Certainly many hospitals, I think, have shifted from the old-fashioned way of having an autoclave and re-sterilizing lots of equipment between procedures to single-use disposable equipment, surgical equipment, radiological equipment, because of fear of infection. Have we lost the balance, Andrea? Have we
I think we can look at this again, and I know that the surgeons are looking at things again as well, where we can actually re-sterilize equipment. For example, in hysterosalpingogram, dilators and things like that can be re-sterilized. We have shifted to plastic models, single use, but we used to very happily use a metal re-sterilized kit. And I think there is a clear saving there. I just want to come back a little bit to what Lorenzo was saying, was that we need innovation that will come late, that will come. It needs to be in the pipeline. But I also agree that we have things we can do now. We have to look at what we have now, how we can all pay attention in our daily practice to reduce everything that we're doing, because it's urgent. And I do think that decision support to make sure that we get it right first time, as it were, we don't repeat imaging accidentally or inappropriately. This is really important because that will reduce healthcare costs and it will reduce environmental impact. And I think the innovations are fantastic, and I fully agree we need lots of research about the contrast and also the cloud, but there's things we can do today. Yeah, we can make it happen.
May I?
Yeah.
There are two things. Something we can do today, and we should do also at home. We know we close the light when you get out of the room. That's okay. Use a washing machine instead of washing by hand the dishes because it wastes less water, all this kind of thing. And we have to learn and take the habit of using these things at home and also at work.
Yeah. Yeah.
And then specific items which are for radiologists, for the radiology department. Consumption with the machine, but they are similar to our fridge, but the recovery of contrast media and so on. So for contrast media, it would be better to have it for after 24 hours. After 24 hours, most, even in a node patient, most of the contrast medium has been filtrated by the kidneys. That could be maybe a subset of the patient you are evaluating, asking them, are you willing to bring me back your liter of urine tomorrow morning? Because that's a real saving. Because you can then, after sterilization, recycle both the gadolinium and the iodine. And that could be a good mode.
But to add on what Professor Derki was pointing, that there are so many unjustified and also unoptimized examinations, I would just like to remind you, I mean, in ESR, we are tackling this issue for many years, and there was a recent study from Luxembourg, which is one of the best organized healthcare systems in Europe, that 39% of CT examinations and 21% of MR examinations were inappropriate. And based on this, we planned a large project on justification of CT. But always the point was in too many exams and cost, but there is actually the environmental aspect that we were not so far aware of it, but this is really a huge thing as well. So Professor Sardanelli, would you comment on this also?
I completely agree with you and Professor Derki. The problem is that there are two contradictory trends, because on the one side we have to limit inappropriate examination. On the other side, for example, recently in Lombardy, the booking system was enlarged to the entire region. So what happens is that usually for CT and MR, we usually did in my hospital a filter, judging what examination is appropriate or not. For a large part of our plan, our scheduling, now is not possible because all the people in all the region are able to book the examination at my hospital. This is presented as a transparency, but it is a disaster because when the patients come, when there is X-ray and or some injection of contrast, we can discuss. But for example, for ultrasound, it's very difficult not to do the examination. And we have false positive, we have incidental finding without. So I think we should try as a society to push for a balance between transparency of booking and managing of appropriate examination different from what is the trend, because regional authorities and health authorities want to offer the complete transparency, and the consequences is an increase on inappropriate examination.
Yeah, but maybe we have to develop a deeper interaction with the patient organizations. And if the patient themselves, they say, we do not want only more availability and quicker examination and less waiting time. We need appropriateness. We need, so it has, maybe this will change the politicians' mind.
We have only a few minutes left in the session, and I'd like to leave with one or two take-home messages. So I'm going to go back to Kees Westorp for this, because you're bringing an engineering perspective to all of this. We've seen how LED lighting in streetlights and in our home lights can reduce energy expenditure very substantially. We've seen how paying more attention to home insulation can reduce our energy footprint. Are there any take-home messages you could give to our audience that radiology departments in general could do, leaving aside the high-end equipment?
Absolutely, and I think there was quite some inspiration both from the presentations as well as from the discussion afterwards, and that is there's so much we can do already today with common sense. For instance, thinking about HVAC, the air conditioning, making sure that it's turned off when you leave. That also applies to the radiology department, the double-side printing. So I think there are many examples where we have to act now and can act now, and that was also underlined during the discussion. The one thing I will say on top of that is what COVID as a positive, and obviously it's a terrible situation, but as a positive has brought us is the acceleration of digital tools and virtual engagement. And so virtualizing while still staying connected with the patient, the radiology department will also have a tremendously positive impact on the environment and our sustainability goals. And in fact, I even believe that it will help, for instance, set that energy baseline, the CO2 footprint, understanding what the key sources of pollution are, such that we become even more targeted today, not in the future, today, in terms of the issues that we address. And that's, I think, the opportunity for the partnership between industry and health systems.
Well, I think that, thank you. The very fact that we can deliver this seminar to the hundreds or thousands of our members who are participating and following this online, that we can deliver that virtually is an indication of exactly what you're talking about. And we have all had to retool a little bit over the last 2 years. Some of it has been negative, but some of it has indeed been positive. And it's possibly made a lot of us think about things we might not otherwise have thought about that might be environmentally important. Boris, can I hand over to you?
Yeah, thank you. So this was, we are receiving really good feedback from our participants online. We received good feedback from Greece, interesting and innovative topic. Thank you for making us all thinking. So this is really something that I think most radiologists don't still think about. And probably we should think about. And as Professor Sardanelli said, these are really crisis time in Europe. Question is what the situation with energy will be next winter. It's very hard to predict anything, but these are some things that we can do in our everyday lives and in our departments where a lot of energy is wasted without need because we didn't think about it. So I would like to thank our three presenters, Andrea Rocal, Professor Hochman and Professor Sardanelli, and our panelists, Professor Marti Bonmati and Professor Lorenzo Derchi. I would like to thank our audience. And you want to say a few words for the end?
Indeed, and I'd like to encourage you all to just think a little bit about your energy expenditure and your use of resources. Some of the practical things we've heard about are things you can apply in your life at work and outside of work. And if you're not already doing some of these practical things, perhaps you might consider introducing them into your daily life. So with that, we'll close the session. Thank you all for your attention and thank everybody for your participation.
Thanks.
Good day.
Very much.
Thank you.
Thanks.
Now I'd like to call our next speaker, Professor Andrea Rocal, to the podium. And Professor Rocal is going to review some of the other literature that exists on this topic.
Thank you, Adrian. I'm really happy to be here talking about shaping the radiology department of the future, talking today about environmental sustainability. And I've had the opportunity to talk about the Department of 2030 in a couple of ways. And some of my colleagues have talked about technological advances and integration with wider diagnostic and hospital systems and research activities over the course of this overture. We've also heard quite a lot about patient-centered care and communication. We've discussed workforce development and training, looking towards training the cohort of 2030. And today, I'm really happy to be able to be talking about sustainability and our environmental impact. Green radiology, is this a dream or a necessity? Of course, it's a necessity. We're working towards net zero healthcare, which is really tough. What is sustainable healthcare? What is the definition of this? Well, the Royal College of Physicians came up with a definition of sustainable healthcare that is the capacity of a health service to deliver healthcare over time with a consideration to future generations. This is what we're looking towards, is what impact do we have on the people coming behind us? We also need financial sustainability, and that's not difficult in this day and age with a lot of cost pressures. We need a societal and environmental sustainability. We know that healthcare generates approximately 10% of USA greenhouse gases. We currently prioritize patient safety, cost savings, and convenience rather than sustainability. How can we reduce the carbon footprint of what we're doing without harming patient care? I've looked at some very interesting papers, and this one again from Switzerland by Elmar Merkel's group, who looked at the energy consumption of radiology in CT and MRI. They asked the question, how much energy do we consume and where could we save? They investigated 3 CTs, 4 MRI, and their adjacent cooling systems. They measured kilowatt-hour energy and integrated the energy consumption with the room usage. And here I've taken an example from the CT. The yearly energy consumption of CT and MRI accounted for 4% of the entire hospital consumption. This was the equivalent to consumption of 852 people in Switzerland. They found that the dedicated cooling systems for the rooms accounted for 44% of all of the energy consumed. In CT, 66% of the energy consumption was identified during the idle state, not really adding to patient care and safety. In MRI, 33% of the energy consumption was during the system off state. And we can see on the histogram, the active energy consumption is actually a lower amount than the idle or on active status. So really, this is an area where we potentially have an opportunity to make savings without impacting on the care we give our patients. How can we reduce energy waste in CT and MRI? I think if we look at the bigger picture, we need industry here to help us. We need the development of sleep modes, standby, and power save modes. I don't know how this is going to be done. I'm not an engineer, but we need really bright people working on this topic. We need heat waste recovery from cooling systems, and we need refurbishment of old scanners to upgrade rather than endlessly new builds. We do need governmental support. Possibly an EU directive could mandate energy savings in healthcare, just as they've done with domestic appliances, hairdryers, hoovers. European Coordination Committee of the Radiological, Electromedical and Healthcare IT industry will be a very important partner to implement this. And what about at the departmental level? We need to ensure smooth and efficient workflows, interestingly, to reduce the time on but not in use. So efficient workflow will ensure that we scan our patients but without a lot of idle time. We need to reduce our idle time. I believe departments of the future will monitor energy consumption. And we need to plan our layout of scanners to share cooling systems and envisage an energy dashboard. Oh, it doesn't seem to be going forward. Oh, there we go. I'd like to now go on to an environmental impact, looking at interventional radiology, and this very interesting study looked at the life cycle assessment of an interventional radiology department over 5 days. They recorded waste generated, quantity of disposal supplies and linens, operating time of electrical equipment, and the life cycle assessment for purchases, plug loads for electrical hardware, data from cooling units, and estimated travel back and forth to the hospital. Mainly, they were looking at drainages, venous access, CT-guided biopsies. These were the most common procedures, so the normal sort of IR procedures. And if we look at the histograms of usage, it's very interesting. We've got gas anesthetics and electricity lighting very low, linens, waste disposal, staff commutes still quite low, electricity of the imaging equipment is relatively low, and then we get a massive uptick when we look at the production and transportation of single-use supplies. We can also see, if we look at the climate control system, that 25% of greenhouse gases were generated by climate control, of which 50% was at night and on weekends, not necessarily when the room was in waste. In action. So I think we need to be mindful about opening kit. We need to plan our trays and trolleys, and where we can, we need to see where we can use reusable kit where appropriate. We've already heard about this fantastic green fingerprint project with the PACS workstations, changing the wait period to standby of the standby period to 1 hour from 4 hours. Overall, there was a 45% reduction in the original consumption. And we can do this now. We just have to think about it. I'm now coming back to that paper that Adrian mentioned from the Canadian group, and I'm happy to see that as I'm a Canadian. Greening the radiology department is not a big mountain to climb. We can all look at small areas where we can make daily changes. The environmentally friendly radiology department will be required in the future. We have a responsibility, and small changes can make a big impact cumulatively. Auto shutdown of PACS, also projectors in the MDT room and computers, motion-sensitive lighting, care with water usage. And we've seen we need to be very careful with our air conditioning and heating because that has a massive impact. We know that from these studies. Also, we can look at biodegradable equipment. In the authors department, 1,000 cups per day were being used for patients in CT and MRI. So we do need to look at waste, biodegradable cups. We need to be able to separate our waste for recycling. We need to have care and attention when we're planning our interventional procedures and use of single-use equipment. We need to identify areas where equipment can be reused rather than just thrown away. And we need to think about laundry, single-use gowns versus washing, etc. And in this paper, there's a very, very nice table that we can use in our departments just as a little checklist to see where we can make small changes, which, if we all did this, would make a big environmental impact. We need to consider the whole life cycle of a diagnostic process, but we need more data. And we have people here on the panel that are looking at this. There are other fantastic investigators. I know Kate Mathurin at University of Michigan is looking at this. We have a departmental environmental champion, Dr. Sarah Sheard, and perhaps each department needs to appoint an environmental champion that can look at this and start looking at our own data. Is a test, for example, of the patient necessary? Using careful vetting of procedures is important. Are we doing the correct test the first time so we don't have to repeat tests? Do we need contrast in every test? For example, another thought is, why not have a radiology passport? We have vaccine passports now. Can we avoid repeat procedures? Departments need to start measuring and evaluating their performance against environmental impact, as we do with clinical audit, for example, for diagnostic accuracy, waiting times, and turnaround times. But we also need government to be behind us. In the UK, the NIHR have just announced a big funding round for net zero innovations in healthcare, and radiology departments need to design projects and apply for this funding and work on this data. I'm very happy to see that the French Society brought out a white paper in January 2022 where they have a broad authorship, including partners inside and outside radiology. And they have 4 main themes: a digital sobriety or lean ICT, New tech, including what to do with heavy equipment and robotics and connected objects, contrast agents, and waste management. So they are launching into a very major project as part of the French national program. So to wrap up my conclusions, technological advances in imaging are moving at a pace. The Radiology Department of 2030 will also focus on patient-centered care with strong communications. We'll have a dashboard for patient experience. We will also train a subspecialized workforce adept at AI, data integration, and patient communication. And I believe we'll have a dashboard for staff training, support, and well-being. But also, I believe we're going to monitor environmental impact and we're going to act to reduce consumption. I believe we will have a dashboard for emissions and waste. But my kids tell me that this is Andrea's world. A world where peace gives a dividend for allowing resources to be funneled into important initiatives such as net zero healthcare. Thank you.